Welcome to another live graphs class. All right, so tonight's class won't be very long. I'm just going to show you the graphical method of solving simultaneous equations. We have actually done it before. However, when we did that class, because I was drawing the graphs, or rather sketching the graphs on a blank screen, and because the mouse was going all over the place, I'm not sure if some of you could really appreciate how we solve simultaneous equations using graph, or maybe you got the basic idea but you didn't see the real beauty of it. So what I'm going to do tonight is to use one of my favorite softwares, and that is the GeoGebra software. I haven't used it in a while. I was playing around with it today, trying to remind myself of what is what. So I'm gonna be kind of groping, but I think you'll get the gist and you'll get it. The message will come home to you even better than when I was doing the graphs on a blank screen. So even though I might not remember all the nooks and crannies of the GeoGebra, I'm going to have to re-familiarize myself with it. But you'll see as we go along. And of course, I have my scholars here who are always helping me out when it comes to the technical stuff. All right, so yes. Okay, so I'm going to play our schedule of live classes as usual to remind you of when we have the classes and what sessions we have on what days. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. Right, so I want to welcome Asar and Imani and John.
Good night, miss.
Good night.
Night, miss.
Good night. All right, and I don't want you guys to laugh at me, when I go on the GeoGebra. I don't want you to laugh at me if you see me fumbling all over the place. I want you to help me. That's the reason you are here, okay? So I'm going to share the screen. All right, so that's the GeoGebra. So the GeoGebra is a software that allows you can plot graphs, you can have access to geometric shapes, uh, to do your demonstrations, whether you want your circles. I should do, I should do a video when I become versed on the GeoGebra. I'm gonna do a video just walking you through it and letting you see all the possibilities you can explore on the GeoGebra. All right, so for tonight, we're going to use the graph section. Are you seeing the graph, guys, on the screen? You seeing the coordinate plane?
Yes, miss.
All right, so that's good. Okay, so what I'm gonna do, because I want to show you when it's accurate and the GeoGebra is accurate, it will plot the graphs accurately. I want to show you how the equation or the functions intersect and give you an accurate reading. So the idea behind solving simultaneous equations, the graphical method, is that you would plot the two functions on the same coordinate plane, the same graph paper, using the same scale, same everything, plot the two functions, and then the point, Imane, what's going on in the background there?
Sorry, miss.
The point where the two functions intersect will give you the solution for the equations, for both equations. You're going to take your x reading and your y reading. If it's that's if it's two linears. If it's a linear and a quadratic, more than likely you're going to get two pairs of readings, because the parabola will more than likely cut the line at two places, so you'll get two x values, two y values. We're going to focus mainly on the linears this evening, but I think I might throw in one or two simple quadratics and see where it intersects with a linear and take our reading. So what I'll do is I'll type my graph. So let's say we have y equals, so I actually type in y equals negative 5x plus 16. So negative 5x plus 16. All right, so that's my line for y equal negative 5x plus 16. And I'm going to plot another line. And that other line is negative 2y is equal to negative x plus 1. All right, so this is the first function, y equals negative 5x plus 16. This is the second function, negative 2y equals negative x plus 1. So those are two equations, two linear equations. Now, as you can see, the two lines intersect each other. At this point of intersection, we find a solution for the equations. So what we do is we would mark from here with your ruler, make a dotted line down to the x-axis. So that's x equals 3. And make a dotted line over to the y-axis from the point of intersection. So that's y equals 1. And that is the solution for our simultaneous equation. So we plot the two lines, and where they intersect, take your ruler, draw a dotted line down to where it crosses the x-axis, and that's your solution for the x. Take a ruler and make a dotted line over to the y-axis, and that is your solution for y. Okay? Now, here's what I want you to do. So, I'm going to give you two more equations. I'm going to give you two more equations, but here's what I want you to do first, guys. Because I know we have done solving simultaneous equations. We have done it the matrix method. We have done it the algebraic method. I'm going to give you the two equations, and you're going to solve them any method you choose. So let me write the equations for you. So x plus y equals 7. That's 1. And 2x plus y equals 10. So I want you to solve it any method you choose. Any method you choose, solve it. And then now we're going to come back and plot them on the graph and see if we get the same solution, because we should get the same solution, whether you solve the simultaneous equations the algebraic way or you solve it the matrix method. You should get the same answer as when you solve it the graphical method. These are just different methods. So Imani, John, Asar, and those in the chat, solve those two equations any method you choose, matrix or algebraic. And for the algebraic method, you can use substitution, you can use elimination. Solve it and tell me as soon as you're done what the values are that you got for x and for y.
Okay, miss.
And then now we're going to plot the two functions on the GeoGebra coordinate plane, and we should get those answers. Let's see. For those who don't know how to solve simultaneous equations using the matrix method or using the algebraic method, substitution or elimination, feel free when all this is over and done to go to the channel Kemet Masai Academy, search by topic, solving simultaneous equations, or you can go on the algebra playlist and look for simultaneous equation using elimination or using substitution, or you can go to the matrices playlist and look for solving simultaneous using the matrix method. So that's not what we're doing tonight, but I'm just throwing this out there because I know I've done this with my students already, and I want to show them that the solutions that they get from any one of these methods will be the same solutions that they get using the graphical method. All right, so welcome Zion, welcome Jamani, and to all those joining us on Facebook, on YouTube, wherever in the universe you are, you're welcome. And I would encourage you to post your answers, post your comments, and really participate in the class. Any solutions yet? How is it going, Imani? Which method are you using?
Miss, I was using substitution. I actually got two, but I'm checking it the other way just to make sure that I'm getting the same answer.
All right, John, which method are you using?
Because I'm using substitution.
How far are you?
I'm at the first step.
First step, John?
Yes, miss.
Asar? Which method are
Yes,
you
miss.
using? Method.
I'm using substitution.
Okay, so you're almost there?
Miss, I have the value for x and y.
Or what did you get for X and for Y?
Miss, for x I got 3 and for y I got 4.
Hold on. Two. Where is my graph?
Yes, Miss, I got the same thing Asar got.
Hold on, I'm searching for my graph. Where has it gone? Hold on, let me go back and search for it. Da. That's not it. Oh, okay. Hold on. Hold on. All right, let's do this again. Uh, okay, so all right, so Asar, you're saying you got what? X is
Miss, x is 3 and y is 4.
and Imani, you got the same thing?
Yes, Miss.
John, anything else?
Miss, I'm going still.
All right, so let's plot them. So the equation was what? X plus y equals 7. X plus y equals 7. So that's that line. And then the other one was 2x plus y equals 10. So 2x plus y equals 10. That's the other one. So dotted line, straight down. X is 3. And dotted line straight across from the intersection. Y is 4. So you are both correct. And if we plug these values back into the original equation, so x is 3, y is 4, 3 plus 4 gives 7. 2 times 3 is 6 plus 4 gives 10. So substituting them back into the equation lets us know that we are correct. If we look at let's use a quadratic, but let's just use, because I don't want to go too deep into the quadratic yet. Maybe next week we'll do some linear and quadratic, but just to use some basic quadratic, let's just use y equal x squared, the simplest quadratic, right? So y equal x squared, we know that's the curve. We should know this curve, this parabola, y equal x squared, cuts the x-axis at the origin, 0, 0. And let's say we want a line 2x minus 2y equals 3. No, not that, not 3. I want it to actually cut. Equals -1. Okay. All right. So what would you say are the solutions for this? Let me experiment with some numbers and see how if I can get some to accurately cut. Yeah, that one look all right.
It's good.
So me see
Yes,
the
that
X
one look accurate. The
There's going
solution
to
will be what?
there's going to be two solution sets.
Two pairs of
Yeah, two
solutions.
pairs.
Mhm.
So the first one would be +2 to +4.
All right, so the dotted line down. So x in this one would be 2, +2.
and the top one will be Y is equal to 4.
And this, so y would be +4.
Okay. Miss
So
the
that's
next one.
one pair.
Miss the next one is
And
negative
solution
one
now.
to one. Miss negative 1 to 1.
All right, so x would be -1 and y would be +1, right?
Yes, miss.
So when you have a quadratic and a linear intersecting, you are going to get two pairs of solution. Two values for x, two values for y, because more than likely the quadratic is or the linear is going to cut the curve at two places. It doesn't always have to happen. Because suppose it cut it at a tangent, like there, right?
Yes,
Yes.
miss. Miss it will
You
say
understand? Right. So you would have solutions that are the same. That's what it would mean. But in most cases though, it's not a tangent, it's actually cutting it at two places. And so you would get an x and y value for this intersection, an x and y value for this intersection. And isn't it true that when we solve quadratic equations, we get two values
Yes, miss.
for x?
Yes,
Yeah,
miss.
we get two solutions for x. And one of the things you must remember when you're doing solving simultaneous equations the algebraic way and you're given a linear and a quadratic, one of the mistakes students make is to find one set of solutions and forget about the other pair. They find x and they forget to plug it in to find y. So remember, you're going to get two x values, two y values. All right, so let's go back to the linear, and I'm going to give you two more linears again.
Miss,
And
are you using
you,
simultaneous equations?
yeah, you're going to solve them just like you just did. You decide which method, right?
Yes.
You decide which method. So here are the two equations. All
Miss,
right, so we have 3x
3x
plus y
y is equal to
equals 9
x.
and 2x minus y equals 11. So solve it, whether you want to solve it matrix method, substitution method, elimination method, any method you want. solve them, get your value for x and y, and tell me. And then we're going to plug in the equations, plug in the functions in the GeoGebra, and see where they intersect for real, real, real.
Miss, could you give me a moment, please? I'm going to log
Sure,
on to another device.
sure, sure. So for either of these equations, you can use substitution or elimination. Usually, for a substitution, I would recommend you do it when the functions have at least one term that has a coefficient of 1 or a -1. And in this case, both equations have a term that has a 1. It's 1y, -1y. So you could make either of those the subject of the equation and solve it like that. You could also use elimination method where you multiply each equation by the coefficient of the other corresponding term. And then just a week or so ago, we did the matrix method. So those videos are fresh on the channel. You can just go and learn how to solve. So tonight, I'm showing you how to solve on the coordinate plane, the graph paper.
You can't rotate your phone.
Any solutions yet?
No, miss, I'm working it still.
How about you, Asar? Any solution yet?
No, miss.
Which method are you using?
Miss, I'm using substitution again.
Okay. How about those colors in the chat? Are you working the
Mm,
equations.
I just got my first answer. I was stuck for a second.
The first one, which one did you solve
I
first?
just
X,
got the first. Miss, I got X.
which is
Miss, I got X is 20.
X is 20.
Yes, miss.
Sorry.
Okay. Plug it in.
Miss,
Yes, sir.
I got x is 20 and y is negative 71.
71. Whoa. So let's see.
Negative 71, miss.
So you're saying you got X is 20 and Y is
Miss, I got
negative,
negative 51 for Y.
neg- negative 51.
Yes, miss.
And John, you got negative 51 as well.
No, Miss, I got 9.6.
9.6 for Y.
Yes, Miss.
All right, so the Y's we're getting negative 51 and we're getting 9.6 and we're getting negative 71. But everybody got 20 for the X.
Yes, miss, I got 20 for the X.
So if X is 20, 60, so 9 minus 60, 40, 11 minus 40. Well, let's see. Let's plug them in. So we have 3x plus y equals 9. And we have we have 2x minus y equals 11. Oh, but I'm not getting those big numbers, guys. What solutions we're getting here? Based
Miss,
on this, we're getting
40.
x is 4, and y is what? Negative 3, you know? So how you guys came by, I'm curious to know. Well, let's plug these in first and see if they make sense. If x is 4, 3 4 is 12 minus 3, that gives
Oh,
9.
miss, I just did it again when I was showing John something. I actually
Mhm.
got X is 4, Y is negative 3. I was, miss, the first time when I was substituting, I used the 3X. Oh, I switched around the signs for one of the equations. So that kind of,
Okay.
yeah, threw me off.
So we would have 2 4 is 8 minus negative 3, that's 11. So,
Yeah.
Asar, do you see where you went wrong? What were you doing? Substituting, right? So which one of them did you make the
Miss, do
subject of?
you, miss, do you want me to, go through
Yeah,
it?
I want you to walk me through it. So which one of them did you make the subject of the
The top
equation?
one.
So you had
Y.
y equals,
Actually, let me check. I had y equal 9 minus 3x.
all right, so you had y equal 9 minus 3x. And then you plug that in here, right? Sorry, here.
Yeah.
Because it's, so you'd have 2x minus 9 minus 3x equal 11. Is that what you had? 2x minus 9 plus 3x. Is that what you had up to this point? Or you see where
Um,
you did something wrong at this point?
I didn't have plus 3x.
Plus 3x. This one here. So negative times negative. So we'd have 5x minus 9 equal 11. So 5x equals 11 plus 9, which is 20. And if 5x is equal to 20, x must be equal to 20 divided by 5, which is 4. And then you would plug that in now in this equation. 3 fours 12, and take the 12 from 9, you'd get negative 3, right? All right, so I have one more set of equations to give you guys. One more set, and we can wrap it up. And then next week now we'll do quadratic and linear and see how they intersect. All right.
Yes.
So the two equations are negative 4, hold on. So negative 4x plus 3y equals 1, and 6x minus y equals 2. All right, so work those. Work those and tell me what solutions you get. And then we will actually plot them and see.
Miss, I got x equals 1 over 2 and y equals 1.
So you're saying,
I'm going to plug them in just to make sure.
you got x is a half,
Yes, miss. And y is
y
1.
is 1.
Yes, miss.
All right. Anybody else got solutions?
Miss, for my y, I have 1 plus 4x over 3.
Hmm? You want one number, whole number or fraction, one number. How y is 1 plus 4x over 3? Oh,
Miss, y is
you
equal
mean
to,
when oh, you're, so you're using this equation as in substitution.
yes, miss.
So you would have y equals 4x over 3 plus 1 over 3. That's what you're saying?
Miss, I have y equal 1 plus 4x over 3.
No. If you are bringing over this, so you would have 3y equals 1 plus 4x, right? And then you'd have to divide all of that by the 3. So you'd have 1 over 3 plus 4x over 3. Not just the 4x would be divided by 3, the 1 also. You'd have to draw a line under the two of them and put the 3. But I would not recommend you use substitution when the coefficient is not 1 or negative. You could use this one. So y would be equal to 6x minus 2. That's easier to use and plug that in here. Now that you can't do it when the coefficient is not 1, but it's just that you're going to end up with fractions, which some people find challenging to work, algebraic fractions. So if you can avoid it, then you do. So since the y here has a coefficient of -1, it's easier to bring this over, make it positive. So y would be equal to 6x minus 2. And then you open your bracket and plug that in here. And then work out your solution. How is it going, John? I'm not hearing from you.
I did something wrong.
Miss.
Yes, sir.
So, oh wait.
Did you plug in the solutions, Imani? Did they work?
Yes, miss, that worked.
They worked?
Yes, miss. 6 on both sides. So you get 7, 13x.
All right, so let's go ahead and plot them.
And that's how you get half.
So the first equation, -4x plus 3y equals 1. And other equation, 6x minus y equals 2. All right, so there's a solution right here. So x is a half. X is a half.
Yes, miss.
And y is
1.
y is 1. Let's work them substitution and elimination method, right?
Okay.
All right, so let's work them substitution. So if we have -4x plus 3y equals 1. All right, we're going to use this now to substitute. So we're going to make this the subject of the equation. So if 6x minus y gives 2, then 6x minus 2 gives y. So y is equal to 6x minus 2. We're going to plug that here. So we'll have minus 4x plus 3 times, plug in this value where y is. So we'll have the 6x minus 2 equals 1. So -4x, and 3 times 6x is 18x. 3 times -2 is -6. -4x plus 18x is what? 14x. 14x is equal to 1 plus 6. 14x is equal to 7. So x is 7 over 14, which is a half. All right, so if x is a half, we're going to plug that value here, put half where 6 is. So it will be 6 times a half minus y equals 2. 6 times a half is 3. So 3 minus y equals 2. So 3 minus 2 equals y. So y is 1. So this is the substitution method. So let's work them the elimination method. So we'll have minus 4x plus 3y equals 1. That's equation 1. And 6x minus y equals 2. That's equation 2. So we can multiply this equation, multiply that equation by 1 and this equation by 3 using these two. So we'd have the same equation at the top since we're multiplying it by 1. And that's equation 3. Multiplying each of these by 3, we'd get 3 sixes 18x minus 3y equals 6. That's equation 4. So one is positive, one is negative. We're going to add them. We're going to add them to get 0. 3 plus negative 3 is 0. So we're adding equation 3 and 4. And when we add them, we get 14x equals 7. X equals 7 over 14, which is a half. So again, we end up with x is a half. And once x is a half, we'd plug that back into this. So we'd just left back right here. Plug in the half into this equation, and we'd end up with 1. So this is substitution method, elimination method. That's algebra. We could have also worked it using matrices, right? So we just love to show off, and we love to show off with all the different methods that we can use to work out our mathematical problems and come to the very same exact solution. That's the beauty of it. All roads lead to home. No matter which route you take, you're going to get home. That's the beauty of mathematics. All right, so like I said, next week when we're doing graphs again, we're going to focus more on solution of simultaneous equations where one of the functions is quadratic and the other is linear. All right, so any questions, scholars? Everybody good?
No, miss, it's
You
perfect.
understand what we did tonight?
Yes, miss.
Sorry, you understand what took place tonight?
Yes, miss.
Sorry, you doze off?
No, I'm fine.
John, you good?
Miss, he's drinking water. He said he understands.
Oh, he's drinking water. All right. Okay, so everybody good. Okay, I'll
Yes,
see you
miss.
tomorrow then.
See you tomorrow,
Thanks for
miss.
dropping by. Enjoy
Yes,
your
miss.
night.
You too.
Promise.
Bye.
Bye, Asar. And thank you to scholars from wherever you came. Thank you for your participation. Here's the schedule of live classes as usual. Hello CSEC math students, I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything, make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars, did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.